Hi class, it's me, Mr. Morris, and I want to do just a few more example problems to do with hybridization and sigma and pi bonds. First thing that we want to do, we're looking at HCN, and we want to identify total number of electron groups around the central atom. Central atom here is carbon, and even though this is a triple bond, it counts as one electron group. And this counts as one electron group. So we have two electron groups. Because we have two electron groups, our hybridization is going to be sp. One s group, and the next thing we go to is p. So we have one s and one p. They hybridize to make two sp hybridized orbitals. And then we want to look at the number of sigma bonds. Well, I see that I have two bonding electron groups, so that means I've got two sigma bonds, two regular bonds essentially, and then pi bonds you could think of as extra bonds, or they're the bonds that, remember, they overlap with perpendicular, with p orbitals that are perpendicular to the internuclear axis. And since I have a triple bond, that means I've got two pi bonds, which means if I look at my Lewis dot structure, then the total number of bonds, sigma bonds and pi bonds, should add up to be the number of lines that I have, or pairs of electrons being shared. And it does. 2 plus 2 is 4, 3 plus 1 is 4. All right, let's look at SF4. Well, I have 4 bonds, and then I've got this lone pair right here. So 4, that makes 5 electron groups around the central atom. If I have 5 electron groups, that means I've got S, that's the first one. P can only have 3, because we have 3 orbitals in the p sublevel. So sp3 gets us to 4. I need one more, so that's going to be sp3d. The number of sigma bonds, it's just regular bonds. I've got 1, 2, 3, 4. I've got 4 of them. And since I don't have any double or triple bonds, I have 0 pi bonds. All right, SF6. All right, I have 6 electron groups. Each of them is a single bond, 1, 2, 3, 4, 5, 6, because I've got 6 fluorines being bonded to the sulfur. All right, my hybridization, well, S would take care of 1, and then I can do 3 p orbitals, so sp3 gets us to 4. I need 2 more, that's got to be from D, D2, and you add those up, you get 1, 2, 3, 4, 5, 6, which is what we have. We have 6 electron groups. The number of sigma bonds, regular bonds, is 6, and we have 0 pi bonds. Should be able to do all of the practice problems now. We've wrapped up our notes on Vesper and hybridization and sigma and pi bonds. Let me know if you have any questions.